one of the main reasons of the 95% failure of Gen AI is failure to understand the context of the problem, failure to make integration with existing systems a first-class concern. Alignment is more important than your data, that if the humans aren't aligned, then your systems are unlikely to succeed.
Hello, and welcome to another episode of the Decision Intelligence Lab. We've been doing this podcast for several months now, and yet we've never defined decision intelligence for our audience. That's the kind of thing I would never let my students get away with. I can't believe our readers and our listeners have let us get away with it this long. We're going to rectify that today. Today, our guest is Dr. Lorien Pratt. She's the co-founder and chief scientist of Quantellia, a company that's really been a pioneer in the space of decision intelligence. And Lorien has actually kind of planted the flag in a couple of different ways around what decision intelligence is. She's been evangelizing it for more than 15 years. She's written a terrific book called Link, How Decision Intelligence Connects Data, Action, and Outcomes. And more recently, the Decision Intelligence Handbook, which I've been poking around on as I prepare my class on decision intelligence and digital transformation with my students. She's also the co-founder of OpenDI.org, which is working on standards to kind of help us communicate more effectively about decision intelligence, the different components of those types of decision intelligence systems. So on behalf of my co-host, Michael Watson, and myself, I want to welcome Lorien and hand it over to Mike to get us started.
All right. Yeah, welcome, Lorien. Thanks for joining. And why don't you start us off and define, what is decision intelligence? How do you define it? And, why is it so important right now?
Absolutely. Decision intelligence combines data, actions, and outcomes in order to help with two kinds of decisions that we can start to get into in a minute. It is meant to be a unifying framework that helps us organize. I guess I think of the world of data analytics, optimization, econometrics as kind of an octopus that's constantly moving and changing. And decision intelligence is meant to be the glue that gives us a unifying framework for understanding how all those pieces fit together, unified around business outcomes or things that we can measure in order to achieve our goals.
So you must there must have been something when you thought of this that you were seeing some gap between all the octopus of tools and actually taking an action and making a decision. Is that how you got thinking about why we needed this space of decision intelligence?
Yeah, I'll give you a slightly long answer to that. I was an
Yeah.
academic. I have 3 computer science degrees, a master's and a PhD in AI. And I was fairly senior. I invented something called transfer learning. I was on the program committee of the NeurIPS conference. And through a series of circumstances, I moved from that sort of academic world into being a technology analyst for Frost & Sullivan. And so I go from building the solutions to interviews with people who might use those solutions. And I was just the shock of my career. I found nobody even wanted spreadsheets in the room, let alone data, let alone
Okay.
AI, right? And so there was this chasm which persists to this day. I just did a survey of enterprise architects, and their top concern is the chasm of communication and effective integration between all that data, wonderful data stuff, and leaders who need to make decisions to drive business outcomes for their organizations, whether it's a business outcome like profitability, or even something for constituents for a political campaign.
Hey, Lorien, I want to kind of drill down on that a little bit. When you say they didn't even want spreadsheets in the room, what do you mean by that? What was their revulsion or discomfort?
Well, it was a year-long interview project, and their discomfort was every time they talk to the data people are talking past them and aren't speaking their language, and so they're just fed up. And hundreds of leaders in many, many different verticals all said this. And it was a shock. I assumed that if I was publishing in the top journals and, AI and data, that there was some translational mechanism that would get that really great research and those great algorithms to actually be used. And that is true, for certain OR problem sets that you guys know really well, some use cases in which, of course, that's happened. But I assumed that was much broader than it was. And it turns out it looks like it's just these point use cases that are able to use data effectively. And of course, Google has massive amounts of data, and so it knows how to do ads and content. Facebook, massive amounts of data. So we have these sort of exceptional use cases that are not representative of what, like John Deere needs or the state of Missouri or these other non-digital native organizations. Those are the ones who are allergic to the data.
Yeah, the metaphor that I talk about as to why data science, optimization, AI projects fail so often is that we build really well-engineered bridges that only go halfway across the river
Exactly.
and declare victory. So, um, let's drill down on it a little bit. I did in a previous conversation you and I had, you talked about DI kind of growing out of something that you originally had called decision engineering. Can you give us a little bit of history on that and kind of where you
Sure.
started, why things have shifted, what's changed?
Sure, but as a teaser, I'm gonna say it turns out the decision is not as good as the data, and it is not always good to make your data better and better over time. So I'm just trying to pierce one of our
Okay.
core beliefs. So we'll lead up to that. So decision engineering says we've got these decisions that these leaders are making that I interviewed in that year in 2008. And it's a complex thing that involves a lot of different stakeholders who have different jobs. Well, how is that different than building a blueprint before you build a building or working in CAD before you construct the airplane? Humanity, when it creates complex artifacts, creates a diagramming discipline, creates a way of drawing a picture of that because there's a limit to how much sort of linear talking or text can capture these very complex entities. And so design says that we draw a picture of something before we build it. And so it turns out decisions can be designed if we have a standardized way of drawing those diagrams. Not unlike, the creation of Gantt charts before, there was a time we had projects before Gantt charts and NASA invented Gantt charts to have a standardization. And of course, when we have that diagram methodology, it allows people to work together more effectively.
Can you dive into that, diagram methodology? I've saw it on some of your websites, but can you give the listeners, like, a view? Like, what is it? Like, what do they need to diagram when they're thinking of a decision? Like, how does
Sure.
that
So the
work?
second really exciting moment of my career, the first there was a gap thing that I didn't know existed. The second was after these hundreds of interviews in 2008, 2009, I realized people had like this shared mental model. I was asking them, what should technology do for you that it's not doing? And they say, well, I'm incented this month. I have a bonus this year for reaching, these certain outcomes, these measurable milestones, or, a politician doing certain things for his constituents, getting reelected, or a sports person winning the Olympics, et cetera. And the technology just doesn't address my business outcomes. And then I clicked into that and I said, well, how do you think about that? Well, I'm trying to decide, who should I put on my squad for downhill skiing or which elements should be in my policy. And so they were clearly making some choices in the outside world, not in the digital world, that
Yeah,
would and then I said, okay, we've got some choices, we've got some outcomes. And then there'd be some causal chain, and they would describe these causal chains. I didn't say causal AI or causal chains. They
yeah,
just said, and then these things happen in a context. So we draw a diagram where we first talk about the outcomes, and then we talk about the actions that would lead to those outcomes. And then we talk about intermediate things that we can measure along the causal chain. And then we talk about externals. And I found, and this is so exciting, that was a universal template for how people are talking. I later realized that's operant conditioning when behavioral psychologists talk about my dog doing
oh,
something, antecedent behavior consequent. And so it maps to that exactly. And that's really exciting. Oh, and this is I had my teaser before. This is why the data doesn't matter. Once you have the action to outcome map, you then can situate the data that's relevant within the context of those outcomes. Every single project I go into, the people in the organization I'm working with, they are not even in sync about the outcomes that they want. So how could they
mm,
possibly be in sync about the data that supported those outcomes? And so some of the data is relevant, other of the data isn't relevant. So you can have really, really crappy data in some fields and still make great decisions, but you won't know which is which until you put it into that decision context and decide which data the decision is sensitive to. So that's why I say you can have really terrible data and really great decisions, and we're over engineering data way, way, way too much right now.
Yeah, I feel like there is this sense of the general public or the C-suite will kind of get rock brain locked into some concept. Oh, we need to be data driven, or now we need to get deploy AI without really a whole lot of thought.
It's
And
data theater and it's AI theater, and they're doing it
Mm.
performatively as opposed to integrating deeply into driving business value.
so we like to, Lorianne, as the operations research community, really think that we've always been focused on decisions and really specific decisions. I'd love to get your take on how DI and operations research either connect or have historically disconnected.
Well, what I just said is completely false for operations research. Of course, the data matters in the use cases that you guys address. Of course, the higher quality data makes higher quality decisions in the use cases that OR has typically addressed. But my understanding, and I'm only very recently having some more substantive OR conversations, is OR wants to open up new use cases, right? That haven't traditionally been on the radar. And if that's the case, then decision intelligence has a role to play. And so I think, and I'm interested in your guys' thoughts and feedback because this is fairly new for me, that decision intelligence gives you a step-by-step process of formalizing a new use case that has never had data or AI as part of it, and then starting with the business outcome and then working backwards to creating that causal decision diagram that we talked about, and then implementing that in a digital twin or a simulation tool so that you can see where the optimization fits in, where the machine learning composite gets chained together. And we're seeing a lot of orchestration of AI methods, but other things too. It's not just AI. You can have an econometric model here, machine learning model there, human causal link, from a logical like neurosymbolic AI link here. We're seeing these very heterogeneous models over which we need to do optimization. And so the original formulation of DI said, help me model how actions lead to outcomes, the forward model, right? OR
Yeah.
gives us solvers that say, given this model that we have, which is usually very highly nonlinear, often has feedback loops because the real world has
Yep.
complex system dynamics. OR solvers give us an optimization technique that lets us find the best actions that lead to the outcomes. It gives us a way of searching in the space of actions and scenarios, those external combinations of externals, to say, within the likely scenarios, what are the best actions we should take? So DI lets you create the map. OR gives us solvers that let us solve that map to find the best actions within the likely external context.
And from what I understand, I guess you would agree with this too, is that you would almost suggest like your framework is a good way to even frame what the optimization model should be. Like if you start thinking, here's the outcomes, here's the actions that might lead to that, here's external factors. You go through that process first, like thinking and building the blueprint, then maybe you plug in a model. And I think you would argue, like, correct me if I'm wrong, you would argue that makes your operations research, your OR model, your optimization model is better. Is that a way
It
to
makes
think
it
about
better
it?
in that it allows OR to be applied to a hugely larger set of use cases. Right? Now, am
Right.
I gonna come in and do some routing optimization with decision intelligence? No. You guys have got that solved, you've got it well formulated, right? But
Yep.
am I gonna do some pricing or marketing spend optimization, or where should we expand our business? Or, where should we do some digital transformation? Absolutely, because absent decision intelligence, we have no way of having those senior executives who are allergic and have been put off by the data tech people. They're just talking past each other all the time and they
Yeah.
won't let them in the room, and they'll fall back and now it's the highest paid person in the room, or they'll make their decision and then they'll retroactively create the data that helps to justify the decision that they already made. And that's very, very widespread, is that sort of data theater performative
Yeah,
back
I, uh,
solving work.
I like to call it, we strive for evidence-based decision making, but we often end up with decision-based evidence making.
That's
Decision.
brilliant.
Uh,
Decision-based evidence
but
making.
but but I do want to push back a little bit around pricing. Caught my ear partly because my first job in operations research after graduate school was at a company that did pricing optimization for a living, and we just had a guest from my days in that business on the podcast a couple of weeks ago talking about pricing optimization within a couple of different spheres. Um, my feeling is that we're quite good at developing models to optimize prices given the objective being clearly stated. But that often with regards to pricing, it's that the objective is diffuse, that there are some primary things we're trying to accomplish, but we've got things like market share, cash flow, what have you, that are broader than what we've put into the optimization problem.
Yeah, and this is what I see pretty uniformly is that we sit within one silo and we don't understand that there's this interaction between marketing spend and pricing and reputation and brand. And decision intelligence says, let's put all of those in the same model. So here's an example. Let's say you charged a little more, and so your demand is a little bit lower, but with that extra revenue, you invested that in marketing, and that gets a net promoter score feedback loop going, right? And because we're not modeling that complex system dynamics feedback loop, we don't realize, because we're just sitting in this narrow pricing optimization space and not integrating pricing with marketing, with technology, we're not finding that optimal solution to a situation. And DI has a position on that. It says, let's model all of those pieces and understand how they interact and what are their trade-offs.
Is the DI modeling, is it iterative in the sense that, because I can imagine it can be both qualitative and quantitative. Like it could be, the first pass could just be, here's what we think happens, and then there must be a level where you sort of quantify that. Is the quantification of that, is it different than like building a model, or is building a model part of the DI process to quantify these
What a great
relationships?
question. We usually work in a diagramming tool, a collaborative diagramming tool to start with. And that is very highly qualitative. All we're trying to do is figure out the dependencies and at best, whether it's a positive or a negative impact between one
Okay.
dependency and another. And then, yes, we work through a process at the end of which is this digital twin model of how, actions in the real world. And let me be really clear. A lot of agentic AI right now is focusing on the digital world. We're modeling what's happening outside the
Mm,
computer, not
right.
just planning to create a document or planning to create email, but what's happening with our customers or a market or things like that. Once we have that digital twin model, we then run simulations, and then those simulations can then be compiled down into rules. And I think this is such an important point. There's two meanings of the word decision that's out there, and it's really important to tease these apart. One meaning is some decision I'm going to make in the actual outside world. I'm going to take an action. It's going to lead to a thing. It's that each of these things are measurable, ultimately will lead to an outcome. That is not the same kind of decision that we talk about when we're in the digital world and we're deciding to dispatch, this car to this location, which can be rule-based. We're not simulating necessarily the whole world when we do that. We're compiling down previously created simulations in order to come up with rules. So there is a kind of decision that says, let's look at all of this data about this applicant for a loan. Let's decide whether to underwrite that loan or not, right? Data in, basically data out, binary data.
Yep.
And we can do that through a set of rules that don't necessarily have semantic reference in the outside world, right? So that's where we would use a decision tree. We'd use DMN. We'd use these kind of modeling languages that let us take data and process that data into a decision which is a prediction or we should underwrite, fundamentally different than a causal model where we take actions that lead to outcomes. And we use the word decisions for both of those. And because we use the word for decision for both of those action to outcome models, why did we decide to launch a new facility in Dubai? Why? That's not a plan, right?
Right.
It's not we're going to launch in Dubai, therefore the first step we're going to do, the next step we're going to do. It's not a plan. It's not a sequence of events. It's not a prediction. We're going to launch in Dubai because that'll open up new markets. It's a third view of the future, right? It's a causal chain from actions we take into the future, and it's systematically overlooked. So it's this third view of the future that's not planning. It's not prediction. It's taking an action that through a series of events will lead to an outcome. It's the why chain and the how chain, from the actions to the outcomes and the outcomes back to the action.
And yet, we got all kinds of things in that Y chain that are filled with uncertainty,
Yes.
right? And so there's a follow-up question really around how do we incorporate risk tolerance and willingness to kind of go after a goal with some consequences that we don't know whether we'll achieve or not, right?
This is really easy to overthink, right? All we have to do is propagate not just our point values, but propagate our uncertainty envelopes through those models. I mean, that's the simple thing to do. Now, if you want to use a Bayesian model or some kind of an inference thing, and have conditional and priors and all of that, go to town, man. But what's been really, maybe it's a third surprise, it's a lesser surprise. is how rarely these folks who are trying to model decisions for the first time really want to talk about uncertainty. Because, it's sort of a hierarchy of maturity model. If you haven't modeled it at all before, just simply
Right.
knowing the causal chains without the uncertainty overlay has a massive amount of value. And that's the space I've been sitting for 15 years. And very rarely do my customers say, okay, we want to add an uncertainty overlay. They say it's so valuable just to have the point propagation. Oh, and by the
Mm,
way, if they have a nice user interface where they can sort of adjust the externals, they can see, I mean, what's the point of getting uncertainties? Understand the sensitivity and model to your choices and to your externals. Well, you can also get that uncertainty in an much more visual and intuitive way by having a user interface that lets you modify your choices and see, oh, if I make this choice, make it a big swing, a really different price, tiny impact on my outcomes. Or maybe it's a tiny impact and it's a big impact on my outcomes. What I've found is people care more about sensitivity mapping. What really matters? What do I have to measure? Maybe I don't have to measure these 20 external variables because my decision is only sensitive to one of them. And so what I would say is uncertainty does matter. Don't overthink it if you really need to do it, but do sensitivity first because that's what people care more about.
oh, that's great insight, 'cause I've found with these kind of models, it's like the temptation from an engineer's point of view is to throw in all the variables and then come up with, "Here's the answer." And I can see executives are confused because it's like, do I have to really make these 100 real actions in the real world, or is there one or two things I can focus on that'll move the needle? And I'm
Yeah, and
guessing
and
you've
that's
seen
the
that.
problem. Without decision intelligence, we tend to over-engineer parts of the model and under-engineer other parts of the model. I had this one project where we went into this team, and they had a Big 5 consulting firm. They paid tens of millions of dollars to be this giant data center thing, and they massively over-engineered the data because when we went back retrospectively and mapped the decision, the data, about a tenth of that data had all of the impact they needed to model the decision. And so we often do learn that people are over-engineering, and it's because data scientists are not taught to live within that constraints of the particular decision and to communicate effectively with their decision makers. I see this with space agencies right now. There's a huge amount of Earth observation data that could be used for all kinds of, disaster recovery, climate kinds of things, and yet they're gathering everything they can possibly think of, and they're not taking the cognitive capacity of the decision maker into account or the actual needs of their
Mm.
decision maker into account. And if there's a human in the loop, you really need to understand their appetite for how to think about a problem. And data scientists are systematically overwhelming. And what they don't realize is that of all that data, a tiny subset's actually relevant. And oh, by the way, they won't throw you out of the room if you come in and you talk about outcomes and actions and small amounts of data. And so I'm really advocating, we don't need to build giant system models. We need to build simple decision models. Will go a tremendously long way, given that our baseline is folks arguing and the highest paid person in the room wins the day.
Yeah, it's
Yeah.
interesting. I mean, this comes back to my bridge analogy, which is what we're saying here, Lorraine. I think you've helped me see it in kind of nice way, which is don't overbuild the bridge that doesn't make it across the river. Build a bridge that gets you to that decision and it provides a logic structure. And then you can overlay more richness and more submodels on top of it. That's an interesting way to look at it, over engineered and under engineered. I like that.
Yeah, I mean, in particular, machine learning modelers, they often say, "Oh, higher accuracy of your learning model is always better." And that's not true. If you understand the decision, sometimes to get a 98% accuracy would take 6 months of training, and the machine learning model is like one causal link. And to get 60% accuracy would take a week of training, and 60% is plenty good to have a super highly accurate, ultimate action to outcome decision. And so by understanding the decision you're supporting, it tells you the required level of fidelity and accuracy and even the data. And it takes what could be very over-engineered projects and makes them completely tractable. And so, Mike, what you were saying, working iteratively, it gives you that opportunity to deliver something that's better in the space of a matter of weeks. And then, as you said, VJ, to slowly make the bridge better and better over time, but to do it in a well-measured way. First, we measure our baseline. What's the accuracy of your decision now? And then let's just make it a little bit better and a little bit better.
Well,
Yeah,
and in that,
one of my favorite stories early on in this whole machine learning movement was we were doing a forecasting project for a customer, and we had some eager machine learning analysts on it, and they were already building this huge deep learning model, and I'm like, "How do we try moving average? Let's see how that works." And it was like, "Yeah, okay, the moving average actually solves this particular decision." And
Yeah,
I
it's
think
it's
your
funny.
approach
I
just helps you narrow that down.
Yeah, it's funny. Even if you're doing a fully automated, high data-centric machine learning project, beginning with decision intelligence to understand the context of that decision and that machine learning model and what is the required accuracy can be hugely, hugely valuable in reducing the time and effort that's required to build that model. And,
Right.
data gathering, data cleansing. Oh, and then people throw like 300 variables in the machine learning model, and they don't do variable importance, and then they cleanse all of the
Mhm.
fields, and they don't realize that 10% of the fields have 90% of the value, even within just that one link,
Right.
that one machine learning model. So yeah,
Huh.
data scientists are systematically not taught to take a customer point of view. So decision intelligence is like the software engineering of the data and analytics world. It says,
Perfect.
stop, don't start coding, leave the data out of the room until we've formulated the problem accurately.
Wow. So, Lorien, since you're much closer to being a traditional data scientist than Mike and I want to pin you down on this last statement. Data scientists are systematically taught to not take the customer in mind. What do you
Yes.
mean by that?
I've never
And
seen
by
a
the way,
user.
for the record, listeners, I didn't say it, Lorien did.
I did. And again, with the exception of a few use cases, obviously there's some great OR use cases where the customer is well known and the customer is taken into account. Where I'm sitting is the unmapped use cases that have not yet been, digitally transformed or used. So obviously you can argue against me completely correctly with certain spot use cases. But if you're trying to extend into the vast majority of use cases, I talk to these senior data scientists. They say we go into a room and we talk to the business. They call it the business. And the business says, well, what can you do for me? And they say, well, what do you want? Well, what can you do for me? Well, what do you want? And they have no blueprint,
Right.
right? It's like going into a building site and say, we're going to build a building and not having a blueprint with the HVAC and the plumbing on it, right? And it's crazy. Of course, we need a blueprint that shows how my requirements map to your technology. And then the DI handbook and our process says, do this, do this, do this, do this, which says, figure out the outcomes. I had a customer. This is one of the largest universities in the country. They have over 200,000 students. They spent weeks just getting aligned around their outcomes. And, you need to leave the data out of the room. Do not
Right.
talk about your data sets if you don't even know what you're going to measure to know if you were successful or not. And this is universal. And data scientists are taught to have the data in the room. They're not taught to keep the data out of the room until the problem is well formulated. So we're making what are called type 3 errors all the time.
Yeah, it's interesting. A long, long time ago, I worked in a semiconductor fab, modeling and analyzing capacity. And we couldn't do anything at all until we understood the recipes for producing the chips. And in a sense, no data could help us until that was locked in, right? And this is very analogous to that. This way of thinking is very analogous to that, which is, hey, what is the technology is in service of the business. The business is not in service of the technology.
And
How
and
often?
and what's hasn't served us is that the use cases that have the most attention have massive amounts of data, but are not representative of the new set of use cases that we need, which need equal amounts human expertise, data, and other disciplines like behavioral economics, econometrics. I did one with computational fluid dynamics. We're modeling COVID
Cool.
particles flying around the room. So we have
That's
to
cool.
integrate these technologies together. And so DI is the grand integration of all of those things.
How often do you find, like, when you go through the process, just going through the process and figuring out what are the real outcomes we care about, what are the real actions we can take, that it just ends there without the data ever having to come in? Like, do you find that happens occasionally, rarely,
I
often?
would say half my projects are like that. I had one project where we did the causal decision diagram. They laminated it, distributed it to 100 people, and said just the diagram of knowing how the different silos of their organization interoperated was worth $10 million in savings per year, even without any sort of simulation whatsoever. I mean, imagine if you're building buildings and you don't have a blueprint. You don't have to automate the blueprint and put in a CAD system for the blueprint to have value, right? And
Right.
so that was the big shock for me. I'm this technologist, and it turns out what people really need is alignment with each other. And then only after they've got alignment with each other is alignment with the tech have any value whatsoever. Because if they're all in different places, I promise you, whatever tech system you set up is going to be suboptimal.
Yeah, I have a friend who mentors young consultants, and I think he has a good way of saying this too. It's a little different, but similar theme is he tells consultants like, "All right, you're off to build this model. Build the one-day model. Pretend like you just had one day and you had to build something by the end of today, what would you build? You're not going to write code or anything. And I think it's, to your point, it's like helping people think through these kind of things so that they can see the big picture instead of getting lost in the details.
It's sort of the waterfall to agile transition in data scientists. It's like everybody's boiling the ocean and building the decision is only good as the data. Sort of to build a giant data center and take 6 months or a year. And vendors are really doing a disservice to their customers. And
Yes.
customers need to hold their vendors accountable for exactly what you said. Give me your 1-week model. Make it even just slightly better. Tell me, first of all,
Yep.
don't even build a model. How do you measure how it's done today so that we know that we're
Yep.
doing better? If you don't even get to start model building until you know the context for
Right.
that, right? And then, everybody in data science, it's all about the ROC of the AUC as opposed to weighted false positive, false negative, which is a lot more accessible to end users. And they're not even taught to do that. And then,
Hey, hold on a second, Lorien. My students in data mining are taught to do that. We start there, just for the record.
Well, I should start hiring your students because the ones I bring on don't know that. So thank you.
Absolutely crucial. I mean, in some sense now, there's always another classification algorithm. There's always another prediction algorithm that can take more variables and more data. But if you don't understand the economics of it, you can't judge the solutions. You just can't.
And if you look at that MIT paper about Gen AI that came out a couple weeks ago, if you click into that, one of the main reasons of the 95% failure of Gen AI is failure to understand the context of the problem, failure to make integration with existing systems a first-class concern. And just focusing, I call it like a tech fetish or a data fetish.
Yeah.
We're sort of in this world where we had all these really successful data-centric use cases that we've got this tunnel vision right now. We don't realize the next rash of really important use cases will have data and human expertise and use the whole toolkit of the last 50 years of AI and data in order to solve our problems, as opposed to one tool or data source at a time.
So that organically brings us to my next question, which is, I think we have a strong sense that very often the failures that we hear so much about are not technology failures. Um, what does DI do to kind of improve alignment?
It puts
Right,
alignment as a
of people.
first-class activity. It says alignment is more important than AI. Alignment is more important than your data, that if the humans aren't aligned, then your systems are unlikely to succeed. And so it says that causal decision diagram, that simple diagram with those 6 things in it, actions, outcomes, externals, dependencies, intermediates, which is really easy to learn. In fact, I don't teach it anymore. I just go straight when I'm doing a modeling exercise, I just go straight into it and I say, what are your outcomes? And I put little boxes on my tool. So I don't even have to teach it. It's so simple. And it puts that as the first class entity that is preserved throughout the entire process of decision modeling. And so we stay aligned not just between the people, but between the people and the tech. So it's serving as that central mental model that all of the characters, as you're trying to get the tech to solve a problem, can centralize around. So alignment was first class. It's the first most important thing.
I feel like we could talk all day, but maybe to respect your time, let's to wrap it up. Could you explain what your current company is and the things that you're working on now, so listeners can learn more about you and your company?
Sure, I'm Quantellia, Quantellia.com, and we have for 15 years delivered decision intelligence and machine learning solutions to many kinds of organizations, governments, and commercial, large and small. Right now, we are launching a product based on all those custom deliveries so that you can easily build decision models and simulate them yourselves, and it will interoperate with the solvers from operations research. And so
Oh, very
that's very
cool.
exciting.
It is.
Yeah, I do think that there is a whole notion here that DI captures pretty nicely and that we don't talk enough about, and that is we've got a higher level notion of what we're trying to accomplish and what success looks like that is often not stated, not articulated. And once that notion and that causal chain of how do we connect to those outcomes is laid out, then we may need all sorts of different models to do different things to improve our overall decision-making execution. And for the record, and I say this because I just finished reading the handbook, the DI handbook, Lorianne. For the record, I don't have a side around whether these are fully automated decisions or human augmented decisions, because my feeling is that even in the fully automated environment, there's a human accountable for the results. And so they've got to think about the decisions, the metrics, and the causes in the same way. Um, it just all happens faster and in a harder to read way than when the human, am physically executing the decision. But I think that DI really, I think, should, from my perspective, the reason we call this the Decision Intelligence Lab is I had a strong sense coming into this that our decision tools were not leading to better decisions often enough. And so we've been looking at this as a lab environment to help us understand what works, try things, see what other people have tried, and share that information out. And so this is a really helpful discussion today.
It's an interesting moment in history, VJ. You're completely right. In the history of innovation, whether it's cars or cell phones or computers, we have this proliferation of methods, which, we're kind of in the middle of that right now in AI and data and evidence-based decision making. And then there's a moment where we get a new user interface, the browser, right? I mean, I was on the internet and Usenet news groups, for 12, as you were, I'm sure, 12,
Oh
15
my
years, and
God.
email
You're
with
going to
the
make me
exclamation
cry
points.
just with your
I know.
Usenet reference. Oh,
I know. So we were all using the tech before the browser got created, and then there's an explosion because we have a new user interface. And then in addition to the browser, there's a new standard, HTTP, TCP/IP that everybody uses so that everything gets interoperated. Same pattern happens with cars. We have the standardization around a steering wheel plus the user interface of the steering wheel plus standardization about how we build car parts. Same thing in cell phones, same thing in computers. Well, in this new world of data evidence-based decisions, the new user interface is the large language model. And the new integration technology is decision intelligence, which says how all of these great tools from the past, whether we're talking, expert systems or neurosymbolic or deep learning methods or econometrics or optimization from OR, can now be unified into a common interoperable framework such that we get these incredible synergies between all these technologies because now we can glue them together. They don't live in silos. And historically, when we have these two things, standardization, TCP/IP, et cetera, plus a new user interface, everything explodes. And so we are at this moment where the explosion is beginning, right? And so it's not just this podcast that you guys are starting this year, which is a representative of this explosion that's happening in 2025. We're at an inflection point of something really exciting, and it's so new it doesn't even really have a name, right? It's not AI, because AI is just one of the tool categories within this set. It is something like, and you guys, maybe you can figure the name, the problem, decision intelligence is the solution. What's the name of the problem? Is it evidence and data-centric complex decisions for a rapidly changing world? I don't know what the name of the problem is. It's so new, but it's a really exciting moment. And I'm honored to be here on your podcast to get a chance to talk about it.
The piece I would add, Lorianne, is that the pace of change and the environmental shifts now are so rapid that if you don't have a good framework for making your decisions, you're very much like responding to noise, because there is so much noise. There is so much change. The thing I've been saying the last couple of weeks has been there are these three tectonic plates that are being spun around by jugglers. Uh, Geopolitical chaos, climate shift and migration driven by climate shift, and economic change driven by technology. And all these things are bumping into one another and making them all spin in more random and more radical ways. And keeping your head on straight and keeping yourself focused forward is really about what are the decisions I can make? What are the things I can influence? And how do I make those decisions in the best way that I can? So the challenges for management in both mature organizations and younger organizations are harder than ever. And the opportunity, I think, for structured approaches to decision making to help those people has never been bigger.
Structured, understandable, word salads not allowed in the room, right?
Yep.
Folks who want to use this tech need to hold their vendors accountable for fitting into their ways of thinking about things, not you have to learn, Bayesian inference in order to have a conversation with me. And so I think a lot of folks are just like bamboozled by their vendors. We're going to do AI. You have a PhD, therefore I think I'm going to just do it. You must be smart, but I don't know what you're talking about. You can't do that. You can't check out. That's abdication. You have to understand how the technology connects to your business outcomes. And the good news is DI gives you like a structured way of having that communication happen in a way that forces them to have your mental model, and you don't have to like bury yourself under the, open up the hood of the car in order to drive it. That's the transition that we're at.
Yeah, Lauren, we might have to have you on next year because you've just kind of kicked off a whole other podcast episode I'd love to do with you. That notion right there is a really critical one, which is, to what extent does the organization making the decisions need to be catered to by the vendor? And to what extent does the vendor or developer, internal consultant, bring a new way of thinking? And those bridges are, I think, super fluid and are very much about how do we collaborate better in honest and open ways and understand one another better in order to be more successful. So we can't start a new thing there. We're at time, Mike.
We are. Lorien, do you want to have the last word, and then we'll wrap up? Any
Sure. Well,
last thoughts?
VJ, how do we collaborate better? Get the DI handbook, dihandbook.com. It is a step-by-step process for how to collaborate better. And take my 8-week online course, Getting Started with DI.com, also known as Gizwitty, Getting Started with DI.com, where we teach folks how to do that, both technologists as well as non-technological people who nonetheless are, as you say, caught in a very volatile, complex, uncertain, and ambiguous environment. And so it is a place to learn how to solve really difficult, gnarly problems if you've got a decision that's keeping you up at night, even if technology is not necessarily on the radar. Doing decision intelligence in that course and that book are both relevant.
Perfect. All right. Well, thanks for being on the podcast. We really appreciate it.
Thank you, guys. It was a delight.
Thanks, everybody. See you next time.